Well, hello everyone, it's Mr. Freiberg here again, and this is the fourth and final lesson for this first week of Year 7 Maths for Term 2 in the online learning environment. And today's lesson is all about solving problems with volume of rectangular prisms. So applying what we learnt in our last lesson, which was on Wednesday, and applying that to some real life scenarios to hopefully solve a real world or some real world type problems, specifically using volume of rectangular prisms. What you see on the screen is your title. So please, if you are using your maths book, make sure you write that title in your book along with the date which you should be doing this, which is Friday the 24th of April. Again, there are notes available online, and you may very well have downloaded those class notes, of which you can follow through and add the blanks or fill in the blanks as you go through those. Again, please make sure you pause the video at any time so that you can write notes down as you need. So there's the learning intent for today. You'll use your knowledge of volume to solve a range of problem solving and reasoning questions. Again, pause if you need. And the success criteria is that you will be accurately recalling and using the two formulas that we looked at last lesson, and to be able to identify important information in questions to solve problems. So I understand you've done a bit of problem solving in the past, and I'm not going to reteach you how to solve problems, but I might just give you a little bit of the way that I go about solving problems, which may help you solve some of the problems that you're going to see in the classwork today. Again, pause the video if you need to write anything down. Okay. Last lesson, we introduced you to the volume, or perhaps reintroduced you to the volume of a rectangular base prism. And we looked at two different ways to work out the volume of a rectangular base prism. So first of all, we said that volume is the amount of space that's inside a three-dimensional object. We also gave you a little note about capacity, which is the amount of liquid, but we said we don't need to worry about that for the time being. The other thing about volume is that the units are cubic units or cubed units. So like millimeters cubed, centimeters cubed, meters cubed. Okay. We then went through two formulas. The first one, which you should know, is to find the volume of a rectangular base prism, you multiply the length by the width by the height. So over here on my diagram, there's the length, there's the width, and there's the height. And if I abbreviate those to L, W, and H to work out the volume of this prism, you would have gone 10 multiplied by 5 multiplied by 4. 10 times 5 is 50. 50 times 4 is 200. And depending on what the units are, if they were centimeters, you'd have centimeters cubed or cubic centimeters. If you would like to, as a review, it might be a good idea to actually write down these notes again. So I'm going to pause the video, or you can pause the video, I should say, and you can write those notes down, and you can certainly write that example down again if you wish. If not, see you on the next slide. All right, the new sort of material that we looked at in the last lesson was a slightly different way to calculate the volume of a rectangular prism. And this is pretty much the same slide that we had in the last presentation. We said that the rectangular base prism can be made up of several layers of cubes. And as I said last lesson, I believe you had even interacted with some layers of cubes in class. Each of those layers has the same rectangular shape, meaning that there is the same amount of cubes in each layer. So how do you find the volume of this rectangular base prism by counting the number of cubes? Well, as it says there, you actually find the cubes at the bottom, or in other words, the area of the base, and then you multiply by how many layers of cubes you have. In other words, the height of the prism. So you'll notice my diagram over here with all of these lovely layers of cubes. There's the base part, which has got 4 along the length, say, and 2 along the width, and so we know the area of that base will be 4 times 2, which equals 8. And then we've got how high the prism is, 3 layers tall, so if the area of the base is 4 times 2, which as I said is equal to 8, and we multiply that by how high it is, so 3, 8 times 3 gives me a volume of 24. And if these were centicubes, it'd be 24 cubic centimeters. So we looked at both of those techniques last lesson. They're very, very similar formulas. They both involve multiplying three numbers together. One's just the length times width times height, but the other, which is possibly the more useful one, as you can see here on this screen, is area of base times height. So I think that one is a little bit more useful. Again, you might like to write down those notes as a review. You certainly might like to write down the example. And I would recommend that you pause the video to do that, and I'll see you on the next slide. All right, the next slide has got a question for you to try yourself. Now this one I'm going to leave up to you as to which technique you wish to use. Whether you want to use the length times width times height formula, or you use the preferred method, which is area of base times height. So where it says volume here, I would actually probably prefer you to use the formula area of base times height. So I'd like you to pause the video, and I'd like you to have a look at that diagram on the right hand side. It's a tissue box. That's a tissue box. I'd like you to see if you can first of all identify the base, perhaps then identify how to work out the area of the base and the height, and I'd like you to see if you can work out the volume of that particular shape. Okay, so area of base times height. Obviously the base is on the bottom. You work it out by multiplying the length and the width. And there's the height right there, 126 millimeters. So the area of the base, 226 long by 84 wide, and the height is 126 mil high. It's in millimeters, and so your answer will be in cubic millimeters. And if you work it all out, you're going to get a really, really, really big number, 2,391,984, and that'll be in cubic millimeters. You could also, as an extension, maybe work it out in cubic centimeters. Perhaps all of these measurements here, you can change to centimeters by dividing them by 10. That could be a nice little revision from last term. Now you might like to try that yourself. You might like to pause the video, check your answer. You might like to also calculate it in cubic centimeters. But again, I'll meet you on the next slide. Okay, some little points that I would consider important when it comes to solving problems with the volume of rectangular prism. It's important that when you are solving problems involving shapes, you do the following 6 things. And they are, you read the question carefully. All right? If needs be, you reread it so that you get a good understanding of what's going on. I always then like to highlight the key information. If you don't have a highlighter, underline it. Simple. After you've done that, you then draw a diagram. Now, your diagram doesn't have to be a good diagram, but it needs to be a workable diagram that will help you solve the problem. You then write down the rule. So obviously you've understood what's going on, you've drawn your picture, and then you write your rule. So hopefully by now you would have worked out that all of these questions will be about volume. So you'd write the rule for volume. You then do your calculations, and then the last one is you actually need to write a sentence answer. So if I'm asking you a question that says how high is a particular object, you need to actually write me a sentence that says the object will be 17 centimeters high. All Right? Those 6 things there I consider to be important little points when it comes to problem solving. I'd like you to pause the presentation, I'd like you to pause the video, and I'd like you underneath that heading, solving problems, I'd like you to write those 6 points down. In fact, I'd like you to write down what you see on the screen in your maths book right now, and I'll meet you on the next slide where we're going to do an example. Okay, here's an example. Now it's a we do example. Now, as we go through this, the next few slides, you will notice that I'm going to run through each of those 6 points there. Okay, so the first one was to read the question. So the question says an engineering company wants to build a truck body that will hold 18 cubic meters of material. The truck body will be in the shape of a rectangular prism. If the dimensions of the base are 1.8 meters by 4.8 meters, how high will the sides need to be made? And if needs be, you can reread that again. Pause the video and read it again if you wish. If you have the handout already, I've already done the next point for you, which is to highlight the key points. The key points that I found in this question, I've now highlighted in red, as you can see on the video. I can see that the volume, or the required volume, is 18 cubic meters. How do I know it's volume? Because it's got cubic meters. So the engineering company wants to build a truck body that holds that much dirt. The truck body is in the shape of a rectangular prism, so I've highlighted that point. And I've also highlighted a couple of points down the bottom here where it comes to the base. So that could be its width, that could be its length, and you'll notice I've actually given you a clue there how high it will be. So looking at that question, it looks like it's going to be involving length, width, and height, but one of those measurements is missing. That's what makes it a little bit tricky. So I've highlighted the key points, including the measurements. The next step, which was step 3, was to draw a diagram. So there's my diagram, pretty basic, but it's workable. And to also add in the measurements. So now I've just slightly changed the presentation of that slide, and you'll notice I've now put the measurements in there. The volume is 18 cubic meters, so that's the inside of the rectangular base prism. Let's say there's the length, which is 4.8, there's the width, which is 1.8, and the height, well, we don't know what that is, we've got to work that out. So now the next step is to solve the problem. So over here on the left-hand side, I'm going to work out the volume of a rectangular prism. Now the volume of the rectangular base prism that I'm going to use is area of base times height. You might like to just watch this rather than write for the time being. If you have the notes, you'll notice that there is a little bit of a blank there for you to write this in, but you can write that in when I'm done. If it's a rectangular base prism, there's the base right there that I'm just shading in, and it's a rectangle, and we multiply the length by the width. So back over here, I'm going to go 4.8, and I'm going to multiply that by 1.8, and then I'm going to multiply by the height, but I don't know what the height is. So I'm just going to rewrite the height down. You will notice though that there is one other important piece of information, and that's the volume. The volume's 18, so I'm actually going to write that in over there on the left hand side of the equal sign. So the volume's 18, so I'm actually going to write that in. Now I'm going to get my calculator out and do a calculation. I'm going to work out what 4.8 times 1.8 equals. And you can check on your calculator, it's 8.64. So 8.64 multiplied by the height of this dump truck is going to equal 18, because that's the volume. Now how on earth do I work out how tall that dump truck is? Well, I need to rearrange that formula slightly. And this is how I'm going to rearrange it. I'm going to start with the volume, which is 18. And if I'm going to multiply to get the height, the opposite of multiplying is to divide. So if I divide 18 by that 8.64, I'm actually going to work out approximately how tall that dump truck needs to be to have a volume of 18. Now you can check in your calculators, but 18 divided by 8.64 is about 2.08, and that'll be 2.08 meters. The last step is to write a sentence. So I'm going to say, so the height of the truck must be made 2.08 meters tall for it to have a volume of 18 cubic meters. So the height of the truck must be made 2.8 meters tall for it to have a volume of 18 cubic meters. I would strongly encourage you to pause the video here, guys, and really read through what I've done there. If you have the notes, you've got blanks there where you can write the notes in. If you're writing in your book, I would recommend that you write the question down. I'd also recommend that you highlight the same things that I have. I'd recommend you draw a picture, as I have, and then write the working out as you see it on the screen right now, because that's probably the only way that you'll be able to actually work out the height of that dump truck. I'll see you on the next slide. Okay, over to you. You do time. So if you were with us in the last session, we started on unit 6.6, which was volume, but we looked at some basic shapes and basic questions. Today it's going to be a little bit harder. You're doing the problem solving. So on pages 369 to 371, unit 6.6, all about volume, you've got those 7 questions to do. 12, 13, 14, 15, 16, 17, and 18. As it says there again, make sure, once you've finished, that I get a copy of what you've done. You can either take a photo, scan it, you can drop it in the assessment drop box that's on the online classroom, or you can email me. And my email address is also there. If you don't have a copy of the textbook, over the next few slides, you'll find those questions. And again, you can pause the video on those slides so that you can then complete the questions. Or underneath where you found the class notes, or sorry, the questions are in the class notes, or underneath the class notes, there is a separate document just with these questions on it if you wish to locate those from there. There's question 12, 13, 14, and 15. You'll notice that these are called reasoning questions. And so reasoning questions means that I need a sentence answer. And then 16, 17, and 18 are a little bit trickier because they are open-ended questions. In fact, the first one there says a rectangular prism is made from 30 of those centicubes. What are some possible values for the length, the width, and the height? So there's not one single answer, there's multiple answers. And you can come up with those multiple answers, hopefully. As I said, pause on those slides if you wish to complete the questions, or you can find those questions on the class notes or as a separate document. So let's just check in. What have we done today? We've solved problems with volume of rectangular prisms. We've hopefully accurately recalled these formulas. I used that one. And I've shown you a few ideas about how to identify the important information in questions that will enable you to solve problems. I would hope that you attempt those questions and have them completed by this afternoon so that you can have your weekend free to enjoy. As soon as you've completed those, please make sure that you've dropped them in the Dropbox or emailed them to me. And if you are having any dramas, please make sure you email me, or you might even like to start a thread on our discussion board and someone else might be able to provide you with some assistance if I can't get to your question in a good amount of time. Hope you all have a fantastic weekend, boys and girls, and I will look forward to speaking with you first thing on Monday morning next week at 9 a.m, where we will be continuing to look at algebra. So you might like to go back and also have a look at the lesson on algebra from the start of this week, and I will see you then. Take care, everyone. See ya.